All right, hi everyone. So today we're going to look at functions. So you would have done functions before. Just ignore me for don't ignore me, but just to excuse this little bit of a recap. It will be not on the most exciting side, but that's all right. So functions. Something is a function if it's what we call a mapping, and that mapping has a distinct. Every input has for that mapping. Every input has a distinct output. So for everything you put in, you have something that kind of individual that comes out of that. And a mapping transforms one set of numbers onto another set of numbers. So for example, if you have one set of numbers and you can find a rule for that with the other set of numbers and they change into each other, then that's a mapping. Okay, I like to think about functions. When you were in like fourth form and you started looking at functions, you would have talked about function machines, and I quite like this idea. So if we have our machine, because you can think about this in the context of like everyday machines. So here's our machine. Now let's imagine this is a coffee machine. Okay, with a coffee machine, you might be able to get 3 different types of drinks out of it. You might be able to have coffee, tea, hot chocolate. Okay, now if you put in coffee into that machine, then your output then would be coffee, okay, in drink form. If you put in hot chocolate powder, then your output might be hot chocolate. If you put in tea, your output would be tea. Now, if you put in tea though, you cannot have an output also of coffee. So you can't have coffee going in or tea going in and producing coffee, okay? So you can't have 2 different inputs putting out the same output. And this is where we're talking about a function. Every input has a distinct output. So everything you put in, if you put in coffee, you get out coffee. If you put in tea, you get out tea. Okay, everything that you put in has a distinct output coming out of it. Okay, we can have different types of functions. Okay, or different types of mappings. We can have a one-to-one mapping. For example, if we're talking in equation form, say y equals x. Okay, a straight line graph, that's your one-to-one mapping. You can have a many-to-one mapping. Oh, and I should say, and y equals x is a function as well, because for every distinct x value, you have a distinct y value. So for every input, you have a distinct output. A many-to-one mapping is a function such as y equals x squared. Okay, and we say this is many-to-one because for one input, just use a different color pen. If you put in, if you look at your outputs, okay, say this is negative 1, 1 there, and that's 1, 1 here. Okay, so if we're looking at a y value of 1, we could have had an input of negative 1 or positive 1. And in terms of my coffee machine analogy, I like to think of this kind of as, you're putting in coffee into the machine and you get either, a flat white or a latte as an output, okay, or a black coffee, we could say. Okay, so they're still coffee, but they're slightly different in what kind of outputs you get. A many-to-one mapping is, for example, x squared plus y squared equals to 4, which is a circle. Okay, and this is not a function because you've got the same input giving you different outputs. And back home, we always do this thing called a vertical line test to see whether something's a function or not. So if you draw a line straight down it, and that line cuts 2 parts of the graph, now, mind you, it has to be vertical because horizontal is a function, but that cuts 2 parts of the graph, that means that it's not a function. Okay, so a one-to-many mapping is not a function. Okay, so just quickly here, we can say the domain of a function is the possible set of inputs or x values, and the range of a function is the possible y equals f of x is the possible output or y values of that function. Okay, again, this is all stuff you should have done before. Okay, so we want to look at this first example, and we're going to state whether the mapping is one-to-one, many-to-one, or one-to-many, and whether that mapping is then a function or not a function. Okay, so for A, now, these are our inputs in our first circle. Okay, so this is our set of x values and our set of y values. Now we can see if we're putting in an x value input of 9, we get out a y value output of positive 3 and 1 of negative 3. Now, because your input is producing two different outputs, this is like you putting in coffee and you're getting out coffee and tea, okay, that means that this is not a function, okay? So we'll do I, not a function, okay, and AI, is it one-to-one? No, it's not one-to-one because you've got one input and two outputs. It's not many-to-one because that would be having two inputs having the same output, okay, so it's not that. It's one-to-many, okay, because you're going from one input to many outputs, okay. B, now this one is a one-to-one because every one x value gives you one y value, so one-to-one, and II, it is a function. Okay, C. Now, C, this one here, this is also one-to-one, okay, because for every one x value, you have one y value, so this is one-to-one. And 2, it is also a function, okay, because there's no overlap of values. D, now D, if we chuck a horizontal line in that one, we can see that we have the same output, for the same output we have two different inputs, okay, so that's a many-to-one function, and this one is still definitely a function because if you chuck that vertical line down there, it's not going to cross over any two values. Alright, next example, we're going to find the range for each of the following functions. Okay, so first thing is, to think about the range, we need to know the domain, and then we need to think about what that graph actually looks like as well. So for the first one, we've got f of x equals 3x minus 2, and we're told that our domain is x equals 1, 2, 3, and 4. Now be careful, they're actually distinct values, okay, they're not like a range of values, so you're not including the numbers between 1 and 2, or 2 and 3, and 3 and 4, you're looking at discrete individual values. Okay, so my range in this case, we know that this is a one-to-one because it's just a linear equation. Okay, so for every one x value, we have one y value. So to find my range, I'm going to sub in each of these points. Okay, so 3 times 1 minus 2 is 1. Okay, f of 2, 3 times 2 minus 2, what's that? 6 minus 2, 4. F of 3, 3 times 3 minus 2, 9 minus 2, 7, and then my last one, I can see these are going up by 3, I mean the gradient's 3, so of course they're going to go up by 3, so my next one's going to be 10. Okay, so my range in this case is 1, 4, 7, 10. Perfect. I'm just going to use a different colour for the next question. Okay, B, g of x equals x squared, okay, and my domain is from x is less than or equal to greater than -5, less than 5. Now again, I know my x squared function is a many-to-one function. Okay, so when I'm looking at the range, again, I want my smallest y value and my greatest y value, and I know that my quadratic looks like this. So if this is, say, -5 here, and that's +5, neither of those points are going to give me my minimum y value. They are going to give me my maximum y value. Okay, so I can work that out. G of 5 equals to 25, so that's my biggest y value, biggest value in the range. But my minimum one's going to be at the turning point there, and that's when x is equal to 0, because it's just x squared as a function. So I'm going to look at g of 0, okay, which is 0 squared, which is 0. Okay, so my range in this case, I'm going to write y exists for all real numbers where y is the set of 0 to 25. Okay, and that would be my range. So be careful that, you can't just put in -5 and 5 because you would get two lots of 25 in that case. You need to think about what the graph looks like. And again, you guys are at home, you've got access to the internet, use GeoGebra, use that graphing software if you're not sure what it looks like. That's really helpful. Next one, don't rely on it too much though, because you don't get it in your exam. So still try and work out why things are true, but you do have that available to you. Okay, h of x, so this is c, that's equal to 1 over x. Okay, and I'm looking at where x's exist for all real numbers, where x is not equal to 0 but is greater than 0 and is less than 3. Okay, so in this case, it's quite interesting. So obviously we don't have, we can't sub in 0 into here, because that's going to give us an infinite value. Okay, that's 1 over x. You can't divide anything by 0, so we're going to have an undefined point there. That's an asymptote on my graph. And so if you remember, hopefully you did, hyperbola graphs last year. So you have an asymptote here. Now what your graph looks like is it has this shape on either side of the asymptote. Okay, so that's what it looks like. So actually, my x for my range, for anything bigger than 0, any value bigger than 0, my y is infinitely large. Okay, it's really, really big. So I'm actually going to have like a to positive infinity value for my range here. So I just need to work out for 3. So h of 3, okay, that's 1 over 3, which is a third. Okay, so that's going to be my smallest value here. Let's say that's 3. Okay, that's my smallest value, which is a third. So in this case, my range is just going to be that y exists for all real numbers, okay, and that y is greater than or equal to 1/3. Now it's equal to 1/3 because it's equal to 3, okay, and it's bigger, it's everything bigger than that. It's going to actually be infinitely large, okay, as long as it's bigger. Alrighty, so that's the domain and range. Alright, last one. Hopefully we'll get this one done really quickly. So function f of x is defined by, so now f of x is defined by two different functions. One where we're less than 1, one where we're greater than or equal to 1. We're going to sketch y equals f of x and state the range of f. So again guys, if you're stuck on any of this, sketch your graphs. You can make them as unpretty as mine are, as long as in your exam you do it better than me. And yeah, just go from there. Okay, so first thing I'm going to look at, so I've got a quadratic here. So from x, I'm going to mark in 1. So from x is greater than or equal to 1, I'm going to have my quadratic. So f of 1, okay, is 1 squared plus 3, okay, which is 4. So at 1, I have a y value of 4, and then I know this is a quadratic, so I'm just going to sketch my quadratic like this, okay, and that's greater than 1, it's like that. For less than 1, I've got a linear equation. So on here, I'm going to mark in, so 0 is f of 0 is 5 minus 0, which is 5. Okay, so f of 0 starts at 5, and I'm actually going to find f of 1 as well in this case, which would be 5 minus 2 times 1, okay, which is 3. Okay, so at 3, which is down here, now I'm going to mark this using an open circle, because that's not included in this function. I'm using a closed circle for this point here, for this 4, 1 coordinate, because that is included. We've got the equal to at that point, but I'm using the open circle here, and then I'm just going to sketch this linear equation coming down. Okay, so that's what my function would look like. It's not very pretty, but there you go. And state the range of f of x. All right, so my range of f of x. Okay, so my range of f of x is everything that can possibly be greater than here. So we're actually covering all values that are greater than 3. So my range is that f of x is greater than 3. Okay, so all of those points, and that's because we're not including 3, but we are including everything else that's above 3, and that's because I'll just highlight this here. We've got that little bit there between 3 and 4. Okay, next one, solve for f of x equals 19. So for 19, obviously we're going to have two possible values because that's positive. So I'm going to solve for where, firstly, where 19 equals 5 minus 2x, and then also for 19 equals x squared